only mode.
Hi everyone, welcome to Westpak's webinar entitled Top 5 Mistakes People Make When Designing a Package. I am Tim Eels and I will be your moderator and webinar organizer today. Before we start, let's take a moment to make sure that everyone is ready and familiar with the webinar control panel. First, you should have a control panel on the right side of your screen. And you can minimize that panel by clicking on the orange button in the upper left-hand corner, or you can expand it by clicking the same button. Secondly, you have the ability to submit questions using the chat pane located at the bottom of the control panel. We'll be answering several questions today during the webinar. However, if for some reason we're unable to get to your question, or if you think of it later, our presenter Greg will follow up with you by email afterwards, as long as you send us the question. Today's webinar video and slide deck should be available on Westpak's website by Monday. Well, with that, let's get started. Today's presenter is Westpak's Director of Engineering, Mr. Greg Schwinghammer. Greg has been with Westpak for 15 years. He has a degree from San Jose State University in Nutrition Food Sciences with a concentration in packaging. He's had a lot of roles here at Westpak and really knows what he's doing. Greg, the audience awaits.
Thanks, Tim. We're going to go over the top 5 mistakes people make when designing a package. This is the agenda, so these are the top 5. Not knowing your product's characteristics, having sharp items near your sterile barrier system or SBS, not understanding your distribution environment, using too much cushion, and the number 1 mistake we see people making is not establishing pass-fail criteria prior to the start of testing. So I want this to be an interactive session. I want you to ask questions. So Tim's going to be fielding the questions throughout the webinar, and we'll stop and break for question and answer period during the webinar. And so please submit them using the chat pane near the bottom of the control panel there. We're going to keep, like I said, keep this at a fairly high level. If you want more details, please feel free to contact me or Westpak, and we should be able to help you out getting things done. The other thing is we're going to go through each of these in a little bit more detail, and then I'm going to show a case study how we helped a customer solve their issue in each of these agenda items. The number 5 mistake we see people make is not understanding their product's characteristics. Is your product damaged due to shock or vibration? Is it susceptible to environmental hazards like temperature, humidity, altitude? It's going to see vibration during the distribution environment, so how does your product react when exposed to transportation type vibrations? These are things you need to know prior to designing a package, and the number 5 mistake we see people making is not knowing this prior to testing. So we had a customer that came in and had a product, and they said they didn't want to see more than 10 Gs when dropped from 36 inches. We ran it through the standard package test that they requested, and it saw a low of 15 Gs and a high of 27 Gs when dropped from 36 inches. And the cushion system appeared to be optimally loaded, and it was a fairly good design. When asking them, hey, where did you get the 10G number from? They said that they wanted to have a very robust package and protect their product to the best of their ability. We asked them, hey, did you figure out what level your product broke at? And they said no, they just basically pulled the number out of the air. So we suggested that they run what's called a damage boundary curve. And we have a webinar. If you'd like more details on damage boundary curve, you can go to our website under the resources tab and listen to a full hour on damage boundary. But like I said, we're going to stay at a fairly high level here. So we did a damage boundary test, found that the product broke at 50 Gs. So the package was over-designed for the fragility of the existing product. So they were able to reduce their packaging, fit more in a sea container from China, and able to save a lot of money in transportation for breaking 1 or 2 products. Tim, do we have any questions?
Hey there, Greg. So far it's been pretty quiet. No questions yet, but I just want to remind our audience that to use the control panel, the chat pane, and submit any questions that you might have. Also, today's webinar is pretty short, so that means we have a lot of time for questions, and Greg will answer those live. So send them on in. We'll be stopping about 4 more times during the webinar. Thanks.
Thanks, Tim. So the number 4 mistake we see people make is having sharp objects near your sterile barrier system, or SBS. So if you're not in the medical device industry, SBS might be single bleach sulfate to you. But for the medical device industry, it is sterile barrier system. You can see here there's 2 different types of sterile barrier systems we have examples of. The one on the left is a poly-Tyvek pouch. The one on the right is a PETG tray with a Tyvek lid. The customer puts the product in there, seals it, sterilizes it using either ETO, gamma, or steam sterilization, usually, one of those 3. And then we run it through a transportation simulation, and then we'll do what's called a gross leak test. You can see a picture of that on the left. Again, we have a full webinar on sterile barrier system package design and testing on our website, so feel free to go check that out. But that's kind of the high level of what a sterile barrier system is. Now, the thing is, once it's sterile inside, you want to keep it sterile, and so keeping that intact is very important. Here we have 3 examples of ruptured sterile barrier systems. The one at the top is a plastic implantable device that cut through the poly side of the pouch. The one in the middle is a metal canister that cut through the poly side of the poly pouch. The one on the lower right is a foil pouch that had a needle in it that punctured through the foil side of the pouch. And so kind of the way these people solve the problems, the one at the top, they used a PETG tray, which then isolated that piece inside and prevented it from cutting through. The one in the middle, they put neoprene rings around the top and bottom of the sharp edge of the canister, preventing them from cutting through the poly material. And the one on the lower right, they put more restraints on the backer card to hold the needle in place. Tim, do we have any questions?
Hey, Greg, good thing you asked. Jared has a question about peel strength. He asks, how do you determine a Tyvek peel strength specification?
Thanks, Tim. So Jared, if you're talking about how you determine what your minimum peel value is, what you want to do is when you do your IQ, OQ, PQ of your sealing equipment, you'll have your nominal seal value, and you would take that as your minimum seal value that you want to test to. So when you do your accelerated and real-time aging, you can then check it back against your real-time samples. So, Tim, any more questions?
Yes, Greg. Actually, Natasha asks one. She just sent it in. Can you talk about how a blunt object might perforate a sterile barrier system?
The way the blunt object did in the picture that you see there is that there was another device sitting on top of that during vibration, it just slowly pushed it through the poly side of the pouch, which ruptured the sterile barrier. So it depends on how much weight is on top of it. So I can't remember if they had 5 or 6 more units stacked up on top of that. And then, like I said, during vibration, it just sat there and rubbed against the poly side of the pouch. Tim?
That's it for right now, Greg. Hold on. Todd asks one, but we'll hold that one for a little later. Okay, go ahead, Greg.
So the number 3 mistake we see people make is not understanding their distribution environment. So not understanding your distribution environment, know where your product is going to be shipped, how it's going to be shipped. So is your product going to be shipped across the street or around the world? These are the things you need to know, and you want to design your package to protect your product for the distribution environment it's going to see. So if you're using a single parcel environment such as FedEx or UPS, or using a Western truckload shipment style LTL, such as yellow freight or consolidated freight, kind of the difference between those two is a single parcel system. You're going to be having the individual packages thrown around and tossed around. On the LTL, they're going to palletize them and ship them usually pallet loads at a time around. Or do you have a dedicated truck or container for your company, and is that how you ship stuff? Knowing these things will help you better design your package and cushion system for your product. Also, will your packaged products be exposed to environmental hazards during distribution? Are you shipping it in a temperature-controlled vehicle, or is it going to be left up to the local environments, or are you going to manufacture it overseas in a hot, humid environment and then ship it to Alaska where it's going to be freezing cold? These are things you need to know prior to testing. And again, knowing these things will help you answer the question and choose what test standard and what packages you need to design. So an example of a customer that didn't quite understand the distribution environment is the customer came in and wanted to run vibration testing for half-track vehicles per mil standard 810. The picture on the left there is a half-track vehicle. You can see it has wheels on the front and tank tracks in the back. I had asked him the question of like, hey, are you going to be selling to the military? Is this going to be used in a military in-use environment? If that were the case, then we could ask them about what vibration profile they would want to use out of mil standard 810. And they said, no, we're going to be selling this just out on the road in America, so it's going to be transported via truck across the country. Talking to them further, we discussed different vibration profiles, and they decided, with our recommendation, to use ISTA 3A over the road and pick up delivery profiles per the ISTA 3A test standard. If they would have done the testing per the mil standard 810 half-track vibration profile, they may have ended up with false failures and damage that they would have been trying to protect against that it's not going to ever see in the in-use or their current distribution environment. So there's kind of an example of knowing your distribution environment will help you design your package and testing around that. Tim, do we have any questions?
Hi, Greg. Yes, we do. We do have some questions here. Let's see. For this section, how about this one? Chris asks a question: can pressure during flight shipment cause a hole in a vacuum bag?
Thanks, Tim and Chris. That is a good question. Yes, during flight shipment, a hole can be caused in a vacuum bag, and so what you can do is part of the ASTM D4169 distribution cycle 13 is a vacuum test during that, so you expose it to an equivalent of 14,000 feet for an hour, and then it comes back and you run it through vibration, and so you can check to see if that vacuum bag is intact. If you want a more in-world realistic test, what you can do is run it through ISTA 3A and use the optional testing of vibration under vacuum, where there's a vibration vessel placed on, or a vibration vessel placed on top of the vibration table, or a vacuum vessel placed on top of the vibration table, and then place the product in there, pull it to 14,000 feet, and then run the vibration while it's at vacuum to see if you're going to get holes at vacuum. Any more questions, Tim?
Yeah, Greg, Jared asks another question that's pertinent here. If a product will be shipped via LTL and single parcel, does the FDA require that you validate both scenarios, or can one be considered worst case?
Let me loop back to Chris's question. I just saw another one come in. Chris, the standard is ASTM D4169, and then it lists in that standard which standard you test to for altitude. So back to the question on LTL versus, where'd that go? If actually LTL, FDA require that you validate scenarios. I haven't seen our customers run through separate testing for LTL and single parcel. They'll usually just run it through one test, which is a worst case scenario for both. It's kind of more, it's going to see vibration and drop in compression in either environment. So it's knowing which environment you're going to go through and making sure your test captures. If you're going to do both, make sure it captures both. And ASTM D4169, the new version 16, and ISTA 3A both capture both LTL and single parcel environments. If you know you're only going to go through a single parcel environment, I would recommend using ASTM D7386. Tim?
Okay, Greg, Serena asks a question that's really pertinent to problem number 4 that we talked about with respect to sterile barrier. She asks, with regards to knowing your product, is it a sterile, if it is a sterile medical device, then we have to follow an ASTM standard. Would the standard not specify the maximum loads that we have to withstand instead of basing it on load to product failure?
I'm not exactly sure on that one. So Serena, are we talking in relation to compression, or are we talking vibration and drop testing? So if you could send that back in and then we'll answer it, that would be great.
Thanks, Tim. The number 2 mistake we see people make is using too much cushion. How many of you have heard this when you have a damaged product? Well, just add more foam around it, it'll be fine. Remember mistake number 5, not understanding the product characteristics. If you don't know your product's characteristics, more foam may actually cause more damage. Usually the case is take away foam, because you want the cushion to deflect and spread out the duration of the shock, bringing down your deceleration level. Because something, when dropped from a certain drop height, has a certain amount of energy, that energy is going to go somewhere. And if it goes into your products, it's going to be a fairly short duration, high G level input. The purpose of the cushion is to spread that energy out over a longer period of time, which brings your G level down. Westpak did a webinar back in a few years ago called Developing and Evaluating the Optimal Package, which goes into great detail on this subject. So check out our website, and again, it's Developing and Evaluating the Optimal Package. And it's a really interesting webinar. I think I was the moderator on that one, and so check it out. Looking at the graphs we have here, on the left there is the cushion curve, which in the x-axis has static loading pounds per square inch, and in the y-axis has deceleration level in Gs. The one on the right is what's called a vibration transmissibility plot. Again, it has static stress in the x-axis, or pounds per square inch, but in the y-axis it has frequency. And so what you want is your vibration resonance of your package to be above it's going to be above the attenuation line there, but you want your product to be above the attenuation line in frequency where it resonates at. So an example of using too much cushion is we had a customer that had a product that weighed 1,270 pounds, and the bare product resonated at 14 hertz, which means the lowest product resonant frequency of the critical components inside that product basically had a resonant frequency of 14 hertz. When we put that same product in the package, the overall structural resonance of the package was at 16 hertz. So both of those were right in the amplification zone of the cushion system and the product. So they had almost double amplification, causing potential damage to the product. We stopped the test right away because we knew the product resonant frequency and we knew the package resonant frequency, and we suggested that they cut out foam. If you look at the picture or the diagram on the bottom here, the red squares was the amount of cushion that was originally there. We then cut out a bunch of cushion, changing the static loading of the package from 0.1 or 0.71 psi to 2.7 psi, and the black squares were the cushion that remained at the end of the study, and it drove the package resonant frequency from 16 hertz down to 7 hertz, which then put the product resonant frequency of 14 hertz right in the attenuation zone of the package. So a good rule of thumb is you want a 1 octave separation between your product and package. So if your product resonance is 14 hertz, you want your package to resonate at 7 hertz. That way you're most likely guaranteed to have your product in the attenuation zone of the package. Does that mean that you're not going to get damage to your product? Not necessarily. It depends on how robust your product is. So that's just kind of one example of how designing the cushion system or engineering the cushion system and reducing the amount of foam help better protect the product. Tim, do we have any questions?
Hey, Greg, we got a couple of questions here from Todd. Might as well ask him, address these right now. He wants to know, how realistic are the vibration and shock tests?
So we've done several studies for customers where we've put what's called a saver unit inside their package or on a truck and recorded the distribution environment from different locations. So from like California back to Ohio and from California down to Mexico. and recorded the data, taken it, put it into our vibration controller and increased amplification, it looks very similar to the new ASTM truck profile and the ISTA 3A over-the-road profile. So I think the standards do a fairly good job these days of capturing what it sees in the distribution environment. Now, if you have a closed loop distribution environment where you know exactly where your products are going to be shipped and how they're going to be shipped, I would recommend doing that study again. But like I said, looking at the standards that are currently out there, they do a really good job for truck representing the profiles for vibration. And the drops, they're starting to overhaul those in the 3A. They do a lot of corners and edges, and that's to more simulate what it's going to see in the distribution environment. And ASTM in the 2016 didn't update their drop sequences, but they also do a lot of corners and edges and a few flats. So Todd, hopefully that answers your question. Tim, any others?
Greg, we've got one more here from Todd, but I'm going to save it for our last Q&A. I think it's a good one. So take it away, Greg.
The number one mistake we see people make when they're designing a package is not establishing pass-fail criteria prior to the start of testing. You'd be surprised how many people come in and say, just run the test, and you say, well, do you have any pass-fail criteria? And they go, no, we just want to run the test, so go ahead and run it. And then they get to the end of the test and they ask us, well, did it pass or did it fail? And we go back and say, well, did you have criteria for your pass-fail before you started testing? And they go, no. And so then they go back, and it's a lot of meetings at time and screaming and yelling back at their company trying to figure out, did this thing pass or fail? So what you want to do is you want to establish the pass-fail criteria prior to the start of testing. An example we had is a customer came in, they wanted to run a pallet load of food product through an ISTA 3E test, which is a test that's designed to test palletized loads of boxes. So you put boxes on a pallet, stretch wrap it, or band it down to the pallet, and then run it through a 3E, and that simulates that type of distribution environment. At the end of the test, they ask us to do inspections of the product. We asked them, did they have any criteria that they wanted us to inspect to? They said, no, just note any damage that's on there and just let us know if you see anything that's severe. So we took some pictures. There was some scuffing of the outer boxes, nothing major, no damaged product, no leaking of the product. And we send them the report. The next day I get a phone call and said, hey, so did this pass or fail? And I said, well, what were your criteria? You didn't really give us anything to inspect to. And they said, well, it was scuffed, so we'd like you to have a meeting with us. So 6 hours and a week and a half later, they finally established that, it was good. But if they'd have spent the time up front and got the buy-in from all the different stakeholders within their company of what pass-fail criteria are, they could have saved the time and effort, and at the end of the test, known that it had passed right at the conclusion of testing. So that's the number one biggest mistake we see people make, is not establishing that pass-fail criteria before the start of testing. Everybody for their time. We'll kind of go over a recap of all 5 of the mistakes we see people make when designing a package. Number 5 is not knowing your product's characteristics. Number 4 is having sharp items near your sterile barrier system. Number 3 is not understanding your distribution environment. Number 2 is using too much cushion. And the number one thing mistake we see people make is not establishing pass-fail criteria before starting testing. So, Tim, do we have any more questions?
Hey, Greg, we sure do. Let's see. Let's look at Jerome. Jerome just sent in a question. You mentioned the product frequency needs to be below 14 hertz and the package resonant frequency below 7 hertz for attenuation and the vibrations frequency. However, your chart shows the frequency should be in the 18 to 50 hertz range. You want to comment on that, Greg?
Yeah. So looking at that chart was just an example of a vibration amplification attenuation plot. It wasn't the actual one used for that testing. I couldn't find the amplification attenuation plot for that foam material. So you would need to find the one for the foam that you're going to use in your package system. So Tim, any other questions?
Indeed, Greg. Here's one from Chris. Is it possible to test vibration and altitude in a minus 10 degrees C environment? He says this will capture real scenario during air shipment.
Yes, we can do minus 10 degrees C. The altitude vessel we have that we use for vibration was originally designed to test ice cream during shipment, so it can go down to minus 14 degrees C. So it is possible to do that. But no, most pressurized aircraft have the cargo areas heated because they do ship live animals and live product in that area, so they can't let it be exposed to external temperatures. The ASTM standard, I forget what the standard number is for altitude testing, does have an option to do a 24-hour preconditioning prior to altitude testing at minus 5 degrees C. So we can do it at minus 10. I would recommend doing it at ambient unless you're going to be shipping in non-pressurized aircraft. Tim, any other questions?
We do, Greg, and before I answer him, I just want to remind our audience, we've just got a few minutes left for the webinar. So if you've got something on your mind, shoot it on in here and we'll address it. Greg's really good at addressing these things. Let's see, let's take a question from, let's pick Todd. Todd asks another question. He says, how do you determine what conditions your product actually sees during transportation so you're not over-designing or over-engineering?
Good question, Todd. I think that goes back to using the Saver units and seeing that they really compare to what the standards are using these days. It's really good to have that information if you're using a closed-loop environment. For the shock and vibration of the bare product, it's better to do a product resonance search at a really low level and see where the critical components inside your product resonate at, and that will tell you for vibration what you need. Now for damage boundary, you're going to have to break at least one or two products to get that information to design your package. Tim?
Okay, Greg, Natasha's got a question regarding medical device packaging. Are there any pass-fail criteria that aren't covered by ASTM D4169?
ASTM D4169 really doesn't have pass-fail criteria in it. Your pass-fail criteria should be determined by you prior to using D4169. The D4169 is just going to stress your product and package to things that we'll see in the distribution environment. So prior to using the D4169 standard, when you write your protocol for medical device, you should have your pass-fail criteria in there. And usually for sterile medical device, it is 0 gross leaks or sterile barrier ruptures. Tim?
Hey, that's a good one, Greg. Serena's got a question regarding package. Let's see, regarding off-the-shelf items. How do you recommend packaging off-the-shelf items which are already packaged in very weak sterile barrier systems?
I'm not exactly sure what Serena's asking there. How do you recommend packages off-the-shelf items that, wait, where'd the question go? Sorry, Serena. So are you talking about things that are already prepackaged from a supplier that you're using in your package? If you have that, could you let me know, is that what you're talking about? Tim?
Let's see. Steve asked a question. Here we go. My customers ask me to do drop testing on their parcel packages a lot, but they do not have guidance on if I should be using ISTA 1A or 2A. How do I guide them to make the appropriate choice?
Good question, Steve. I would recommend using either 2A or 3A. So if you look at the title of the standards, the 1A standard says it is for comparison purposes only. 2A is what's called a partial simulation of the distribution environment, and 3A is what's called a full simulation of the distribution environment. So 1A is if you're comparing package to package, and it is an older standard before we had the ability to record the distribution environment. 2A, we had a little bit idea of what the environment was, and that came out in the late 80s, and 3A came out in the mid-90s, and that's kind of the thing that we're going towards, is a more simulation of the actual real-world thing. So out of 1A or 2A, I would recommend 2A, but overall I would try and recommend the 3A because it's a more holistic approach.
A question. Do you recall the question you asked her? And her answer is yes. So take it away, Greg.
Great. Thanks, Tim and Serena. So if you're buying off-the-shelf product, I would then repackage it if you are not confident in that sterile barrier system. I would put it inside an additional sterile barrier system and double pouch it or put it in a separate tray. So if that didn't answer your question, Serena, please let us know, and I'll try and get more detailed on it for you.
Sorry, Greg, I'll turn my mic on now. Elizabeth had a question. How do you convince management to let you spend $250,000 to do damage boundary testing on 2 products?
This is one of my favorite ones. So the way you can recommend it to management is, how many of these are you going to build? If you're building one $250,000 product every 6 months, I don't think you'll be able to convince them that you're going to destroy the product, nor would I recommend it. If you're building if you're building hundreds of thousands of $250,000 products a year, which yay for your company, you can say, I can save you X number of these looking at how many field failures you might have and unhappy customers. So that's how I would recommend it. And the other thing is, if you're just doing a transportation simulation, if you can't convince them to do damage boundary, and they still don't want to use the $250,000 product to do that, the way you convince them is, our product is going to see the distribution environment. Who do you want to see if there's issues with the product, the customer or us? So that's kind of, you can look at it that way. Tim?
Okay, Greg, let's see. Here's one from Adam. Adam's obviously in the medical device industry. We design convenience kits which contain sterile syringes. It's becoming more and more common for the manufacturers of these syringes to use thinner materials, which increases the chances of failure. Have you seen this trend? And if so, what are common design solutions that you have seen to stop these from failing?
We have seen our medical device customers starting to use thinner and thinner materials, and it's hard to justify using the thinner material once you get the sterile barrier failures. If you're buying it from a supplier, I would push back on that supplier and say, hey, you're using this thinner material. Could you please show me how you validated this out to be used in the distribution environment and what your sample size and Passfail criteria were? Tim?
Okay, Greg, we've got a question from Kevin. Can you suggest examples of pass-fail criteria for crated or palletized products when the customers have no idea what they're looking for to determine pass-fail?
That's a tough one, Kevin. So if you have no idea what your pass-fail criteria are, I would start with a very basic pass-fail criteria. Is my product still held on the pallet? Is there any gross damage to the product? And put that in the protocol when you write it, because if you wait till the end and then do an inspection and there's a minor scuff on the outside of the carton or the box, and somebody looks at it and goes, well, that's a fail, you can go back to your initial protocol and design and say, that's not what we're testing for. We're testing for a much more gross damage. Is the product still held on the pallet? Is there anything leaking? Those type of things. Hopefully that answers your question.
Hey, Greg, I see one from Kevin Fernandez, our quality manager. How do you recommend evaluating package systems for retail shipments directly to customers, such as Amazon, or you don't have control over the type of protective packaging the retailer uses to ship?
I would recommend getting a few different Amazon boxes and the pillow packs that they use and running your packages through an ISTA 3A or ASTM D4169 through that shipping environment. So I know it's going to be difficult to choose which products are going to go in there with it, but you can do that. You can also run it through an ISTA 3, a small package test, which will give you it has a vibration component inside a bag with a bunch of other products, which will give you the idea of if you are shipping it in a box to someone's house with a bunch of other products, what it will look like. Tim, back to you.
Okay, Gregor, we got one from Brandon. What do you recommend conducting for a single package that is actually being shipped on a unit load? ISTA 2A or what?
If you're talking about a single package that's then placed inside a crate with another unit, I would recommend testing the whole crate as shipped with the unit and the package in there and running it through either an ISTA 3E or an ISTA 2B test. If that package is never going to be shipped on its own, you're basically over-testing it if you run that single package through the 2A. Tim?
Greg, we've got one more. I think you've, looks like two more now. You may have answered Asuka's question a little bit, but let's answer this one specifically. How can we agree on the pass-fail value when the customer doesn't have quantified goals?
There's a couple options on that. You can basically establish them for your customer and say, here's what we recommend as pass-fail criteria for your product if you're the packaging supplier. Or you can call us at Westpak. We can go out and meet with you and your customer and help you establish those pass-fail criteria, because we want to help you guys succeed as our customers and to your customers, so that way that they can know that they're getting a good protective package to protect their product at the least cost they can do. So, Tim?
Okay, Greg, we've got some more questions here. Let's see, Suka asks, oops, sorry, we nailed that one. Jerome, for small electronic devices, less than 20 pounds, do you typically see damage resulting more from shock, drop or shock, or vibration?
On a for an electronic device less than 20 pounds, it's more going to be drop and shock. Usually those systems are so rigid that the resonant frequency of the product is outside of the distribution environment. So most vibration for truck and air goes out to about 300 hertz. Something like that would probably resonate at like 500 hertz to 1,000 hertz. So it's going to see vibration in the distribution environment, but it's all going to be at a one-to-one input to output level. But something that small is going to more likely be damaged due to drop. Tim?
Let's see. Chris asked a question. If your product has several pieces, which can be shipped either together or as individual pieces, is there a worst case justification that can be made? Or do you need to test each piece or each configuration? I'll let you figure that one out and maybe rephrase it. Thank you.
Sure. Kind of looking at the question, I think it depends on the product. So if you have very homogeneous products and you put them in a box and they fit in there well together, you can just test one configuration. If you've got several loose parts that are going to bounce around and each configuration is going to be different, it's going to depend on those configurations. So if you want to send me an email or give me a call, we can talk about if you have a specific configuration problem you're having, we can do that. It's hard to answer in this general area. And to just kind of loop back to Eric's question, instruments in the 150 to 300 pound range are more likely to be damaged due to vibration, because they usually have components on them that resonate at those lower frequencies in the distribution environment and are less likely to see the drops that the less than 20 pound packages see. Tim, back to you.
Okay, Greg, let's see. Bob's got a question here. What temperatures do most of your customers use for environmental conditioning prior to D4169, and for how long?
Good question, Bob. Most of our customers use a 40 degrees C, 90% relative humidity, and then a frozen component either -18 or 30 degrees C and then a hot and dry 60 degrees 15% relative humidity, and each of those is usually for about 24 hours. I've seen some customers do as low as 8 hours, and other customers do as high as 72 hours at each of those conditions. But it kind of depends on your product and the thermal mass of your product, because you want to try and get your product to each of those temperatures for a certain amount of time prior to going to the next one. Tim?
Greg, Jerome's got a question about foam. Which is better, more foam or softer foam?
It goes back to what the characteristics of your product are. So you need to design or engineer your cushion system based on your product characteristics. So more foam may be better if you have a hard, heavy product. Softer foam is better if you have a lighter product that is going to be affected or is not going to be able to deflect the stiffer foam. So it's really kind of an engineering question. Tim?
Okay, Greg. Let's see. Eric's got a question. This is regarding medical instruments in the 150-pound, 100. Oh, you already covered that one, Greg? Oh. Greg, we've got one from Brian. Would you please go into a little more detail on determining resonant frequency of a product and the package material? He says, I deal with single-use medical devices that are commonly under 1 pound.
Good question, Brian. I think that goes back to when I talked about the less than 20-pound electronic devices. So it's the same thing. It's probably a fairly rigid, fairly stiff system. So those are going to resonate. Those products are going to resonate outside of what you're going to see in the distribution environment. So for a medical device, it's more, is it still intact? Does it function properly? And is the sterile barrier still intact? Tim?
Greg, we've got one more, and we'll wrap it up here for Q&A from Jared. How do you determine which to use, ISTA 3A or ASTM D4169? Good wrap-up question.
Thanks, Tim. This is a good question. I get this question a lot. I say it's like pie. You can either have apple pie or cherry pie or peach pie. So ASTM is apple pie, ISTA is peach pie. You can have either pie. Either pie is good. It's what you decide to use and what you want to do. Both of them are going to give you the same kind of, it has vibration and drop and compression, and it has each of them. So I really don't think one is better than the other. It's kind of what have you used in the past. If you've used ISTA 3A in the past and you're bringing a new product or a product modification to market, then I would recommend using ISTA. If you've always used ASTM D4169 and you're same thing and you're going to do ASTM testing, then I would say use ASTM D4169. If you've done neither and you want to pick one, it really doesn't make a difference now. That being said, if you're a medical device customer and you're submitting to the FDA, look at ISO 11607 Part 2 and it will recommend a standard for you. And I think it's ASTM is the one that is in there. ISTA still isn't accepted as a peer-reviewed standard in ISO 11607. So thanks. Tim, back to you.
Okay, Greg, thanks. And I want to thank all of our attendees who hung in there for a good 20, 25 minutes worth of Q&A. There's some really good questions that came in, and our hope is that the questions that were answered provide valuable information to the person who asked them as well as the audience who heard them. So let's see, what do we do? Next thing you're going to receive on this webinar is a request to fill out a survey. So I hope you'll take just a couple of minutes. It shouldn't take more than 30 seconds to complete our quick survey. We really appreciate you doing that. And most of all, any suggestions for future webinars or that you might have, please take the opportunity to send those in. If you come up with some questions later and you'd like to send them in to Westpak, you can send them to Greg directly, and there's his email address, and there's the phone number to our San Jose site. You can also go to our website, and you'll find a place where you can use the contact us link there. And also for resources, we've got a lot of white papers and, of course, over 3 years worth of webinars available. And there's a tab right there on the Westpak resources page. Westpak has 2 laboratory locations here in California, one in San Jose and our lab in San Diego. And we'd encourage you to let me know. That's Tim at westpak.com if you'd like to take a tour. We really appreciate you being with us today. Keep an eye on our website for the next webinar. It'll be sometime in the next year, January, February timeframe. Haven't settled on a topic yet. I want to thank you all again and make it a great day.